Perfect. So, dear Earth, thank you very much for being present today for this event dedicated to the Earth Observation for Sustainable Development Initiative, and more specifically, its disaster risk reduction activity. So this event is part of a series of 4 events taking place today and tomorrow, which in addition to disaster risk reduction, covers 3 additional EO4SD activities dedicated to marine resources, climate resilience, and finally, fragility, conflict, and security. Regarding the agenda, the event will first start with opening remarks from Same Waba, Global Director for the World Bank's Urban Disaster Risk Management, Resilience, and Land Global Practice, followed by a quick introduction of the EO4SD initiative and of the disaster risk reduction activity. The main part of the event will then focus on the presentation and discussion of several use cases, and then we'll have a panel discussion about the insights and lessons of the EO4SD program, as well as the broader challenges related to the adoption of Earth observation technologies. Unfortunately, Same Waba could not be present today. However, he recorded his intervention, and therefore, without further ado, I will hand over to him.
Good morning, good afternoon, good evening, wherever you might be. It's a pleasure for me to join you in this wrap-up event dedicated to the Earth Observation for Sustainable Development activity related to disaster risk reduction. As you all know, the 2030 Agenda on Sustainable Development Goals was already ambitious when it was launched in 2015. Today, we find ourselves that attaining these goals is proving even more challenging because of the 2 major crises we are facing. The first being the COVID-19 pandemic, and the second is, of course, the continued climate change. And moreover, the war in Ukraine is adding complexity, especially in its impact in terms of increasing food insecurity in much of the global south, which, of course, will impact the resilience of many of our client countries. And in fact, this is the first time in a generation that global poverty has increased. So we need to redouble our efforts and investment to achieve green, resilient, and inclusive development. And of course, now more than ever, we need to take decisions based on new evidence that is emerging in a rapidly evolving environment. Therefore, it's especially important for us at the World Bank to leverage innovative approaches and partnerships to support this accelerated transition towards green, inclusive, and resilient development. And of course, to do so, we need to prioritize an evidence-based approach through investments in data, in platforms, and in digital tools. We see big opportunities to leverage space technologies and data to scale up our work. In fact, space technologies can help us accelerate the digitization of our development footprint, provide independent verification and remote monitoring of our investments, and speed up access and opportunity for clients to harness innovative data sets and decision-making support tools. And of course, to be able to do all this at scale. Now, these opportunities are especially relevant for disaster risk management investment, which at the bank last fiscal year totaled nearly $4 billion. And in this case, Earth observation allows us to better understand the socioeconomic exposure of people and their livelihoods, and of course, the changing environments and climate in which we live. The partnership and the collaborative approach that was developed between the World Bank and the European Space Agency, ESA, which started 10 years ago, is a critical foundation in this regard. Because this collaboration matches ESA's Earth observation expertise and capability with the World Bank's strategic and operational needs so that we can achieve global climate and development solutions to the challenges we face and our clients face. In particular, the Earth Observation for Sustainable Development Initiative, the one we call EO4SD, which was launched in 2016, it has helped us raise awareness and increase the adoption of Earth observation data and technologies, not only with task team leaders, but also with their country clients and development practitioners. So the activity of this EO4SD initiative, the one that is dedicated to disaster risk reduction, has especially helped better integrate Earth observation technologies in our World Bank operation related to disaster risk management. So now multiple World Bank teams and World Bank projects have been supported regarding topics that range from flood hazard, exposure mapping, terrain formation, drought monitoring, and damage and reconstructions needs assessment. Examples range from the support to the analysis and monitoring of disasters and their impacts on coasts and urban areas in Banjul, in Gambia, the detection of resilient reconstruction interventions in cyclone-affected areas in Mozambique, and earthquake impact assessment in the Dominican Republic, to name just a few. So in order for us to be able to continue pushing for the adoption of such technologies and integration in our operations, we need to move to the next level. And this is why at the World Bank, we decided to create a new program within the Global Facility for Disaster Reduction and Recovery, GFDRR, which we call Digital Earth Partnership. This new program, Digital Earth Partnership, will complement ESA's Global Development Assistance Program, through which ESA scaling up its support to the World Bank with a new generation of Earth observation services and the continued provision of a second D from ESA. And of course, in order for us to ensure the success of this new phase, it is important to draw on lessons from the implementation of the Earth Observation for Sustainable Development Initiative, which is the objective of this event. So I wanted to thank you all for joining us and wish you an excellent event.
Perfect. And sorry if some of you had a bit of difficulties. I'll be able anyway to reshare, of course, this intervention in order to make sure that everybody has access to this intervention. So to continue with this session and following this great intervention of Sami, I wanted to first come back on the nature of ESA's Earth observation activities. The European Space Agency, which is composed of 22 member states, has been positioned as one of the main actors of the space sector for almost 50 years, with around 22.5% of its budget allocated to Earth observation activities. And so in the last decade, the Earth observation programs of ESA have been extending dramatically. They now include activities that cover the entire spectrum of the Earth observation domain, encompassing both upstream and downstream developments. The Earth Observation Programs Directorate of ESA has three main lines of activities: Earth Science, Copernicus, and Meteorology. And the Copernicus program is a project run by the European Union and the European Space Agency that builds and manages a fleet of Earth-observing satellites called Sentinel. 8 missions have been launched to date, providing data about changes occurring to the ocean, land, and atmosphere of our planet. So therefore, the program provides accurate, timely, and easily accessible information to improve the management of the environment, understand and mitigate the effects of climate change, and ensure civil security. So through this program, there is around 250 terabytes of Earth observation data that are being disseminated daily to society, which represent a huge opportunity for institutions such as IFIs to capitalize on this data and better prepare, monitor, or evaluate the operations they finance. Therefore, as part of its Earth observation-related activities, it has been implementing programs in support of international development for more than 14 years. This started with EO World, which was dedicated to small-scale demonstrations in support of IFI and so World Bank, for example, projects to raise awareness. And that was followed by EO4SD, which has helped consolidating IFI requirements to larger-scale regional demonstrations of EO and capacity building activities. As we're currently engaging in a new phase of the ESA World Bank partnership, namely the GDA program, it is important to draw lessons from EO4SD, which is one of the main objectives of today's event. As a reminder, EO4SD's main objective has been to achieve a step increase in the uptake of satellite-based environmental information in the IFI's regional and global programs through a systematic user-driven approach aimed at meeting longer-term strategic geospatial information needs of both IFI teams, so World Bank teams, TTLs, and also client state stakeholders. The initiative was developed and then deployed through a network of key partners, including the World Bank, the Asian Development Bank, the International Fund for Agricultural Development, the Inter-American Development Bank, and the European Investment Bank. As a matter of fact, regarding the World Bank, ESA's partnership with the World Bank started in 2008, and on the 3rd of December 2015, at the COP21 Climate Summit in Paris, the World Bank and ESA signed an agreement on using information from Earth observation satellites in support of sustainable development. The E4SD initiative actually is structured in sub-activities with different objectives. There are 8 thematic activities, which we also call clusters, and 2 other standalone activities, the E4SD Lab and the Eastern European cluster, which were implemented for specific purposes. And so today, our focus is really on the disaster risk reduction activity. This activity was launched in 2018 and together with the climate resilience, marine resources and fragility activities, and it ended in 2021 exactly. And its main objective has really been to promote the adoption of Earth observation-based products and services into the working processes of IFIs, such as the World Bank, their projects, and while seeking to prevent, for projects that were seeking to prevent or mitigate the adverse impacts of natural disasters in developing countries. So the idea has been to achieve this objective by first carrying out demonstration of the benefit and utility of Earth observation-based information in support of international development projects and activities related to disaster risk reduction, as well as to supporting directly programs or projects at different stages of the project cycle, and also thirdly, mainstreaming and transferring Earth observation-based information into operational working processes of both World Bank teams, as I was mentioning, and client state stakeholders. In order to achieve this objective, a consortium of 8 companies with complementary expertise was recruited to support World Bank teams, and Indra is the company that was leading this consortium. Fundamentally, the support provided was aimed at delivering actionable information in all phases of the DRM cycle, from pre-disaster risk management through hazard identification analysis to post-disaster impact analysis or risk financing, and of course going through rapid mapping. This consortium supported 4 different IFIs across 14 countries on 4 continents, with interventions, for example, in the Caribbean, in West and East Africa, or Southeast Asia. And the largest share of the support was provided for topics related to risk assessment, multi-hazard analysis, or focuses on floods and landslides. So in total, there is 12 demonstration exercises that were performed, 41 Earth observation-based products and or services were delivered, and around 450 people benefited from 37 targeted capacity building activities. So in order to have a more direct and pragmatic look at those activities, I will hand over to the consortium so that several use cases can be presented and discussed. So I'm handing over to you, Alberto. Thanks a lot.
Thank you very much, Alex. Good morning and good afternoon to everyone. It is a. Can you see my screen? But you're seeing my screen that is divided, right? Alex?
We're just seeing you for now.
Okay. Now it works, I think.
Yeah, exactly.
Okay.
Perfect.
Thank you. So as I was saying, it is a real pleasure to me for me to be here. It has been I mean, 3 intense years of work with the members of our consortium and with the bank members as well. And I'm here representing, first of all, my fellow project manager, Angel Utanda, and also the rest of the consortium. So I will be explaining a lot of, details that should be explained better by my my fellow partners, but I have to do it for them. But yeah, as I was saying, it was very rewarding to contact with many stakeholders during these 3 years. It was very interesting to know firsthand the user needs and requirements, to analyze them, to try to respond with Earth observation products and services, to understand what is the impact and benefits of our information. I think it gave us the opportunity to grow as companies, and also to make ESA grow and also develop, fostering development. That is the ultimate goal of this cooperation between ESA and the World Bank. I will be explaining in three different chunks. A family of different demonstration exercises. So we have been cooperating with 12 different bank teams. We have had to make a selection, and it was hard to do. So we decided in the first case to group some use cases that we're aiming to the same thing, that is helping monitoring infrastructures with satellites in Asia. So this group, this cluster, puts together one activity that we developed in Myanmar, assessing the landslide hazard to a road corridor in Chin State, in one of the states of Myanmar. Then in Bhutan, we worked in assessing geohazards in transportation routes, more or less in a very similar topic. And finally, in Vietnam, as part of a different demo exercise, a fellow partner was analyzing subsidence risk in Vinh Long in Vietnam. So this is the context. So there is the same geographical area, but different problems. In Myanmar and Bhutan, we have, they have a problem, especially during rainy seasons, of landslides affecting transportation infrastructures in that mountainous areas. It is important because it prevents from connectivity during months along the year, and I mean it's a problem that has to be tackled. Secondly, in the Mekong Delta, it is an area that is flooded on an annual basis, mixed with exacerbated sea level rise, also subsidence due to over extraction of groundwater or other causes. Especially for Myanmar, as I was saying, there is a problem of landslides in the area, and our cluster was in charge of providing hazard and exposure mapping, as well as capacity building in this area. The stakeholders in this case were not only the World Bank task team, but also the Ministry of Constructions, and this is important, and it was repeated in several cases. There are consultants that are uptaking our information for taking decisions during, I mean, their activity, and those were part of also of the user base. So here there is some metadata of the demo exercise. So it is a 140 kilometers long corridor, and the objectives were to identify landslide hazard hotspots, shape targeted mitigation actions, so prioritize where to invest, and also foster the protection of investments. And these were the family of products that we were delivering. These are, I mean, very targeted products that can be combined together normally in reports to communicate better, and also through the delivery of the databases for the user to use them freely. These are some pictures of the results of our activity. For example, we provided a landslide inventory of plus 770 spots, categorizing the different landslides as a basis for understanding what was the problem. Based on that inventory and using machine learning models, there was a generation of a susceptibility map to landslides along the whole corridor, hence providing that piece of information to the Department of Roads, what are the zones that are more susceptible using different parameters with different importance. All of this based obviously partially in Earth observation, like the landslide inventory, mixed with different models that we have worked on for years. On top of that, we provided with permanent scatterers interferometry the detection of slope instabilities. That's the understanding of how the slope is movement, and in that case, using that as a precursor of a potential landslide in the future. And finally, a kind of a product that complements that uses the previous projects, the previous results to detect what are the chunks, what are the road segments or slope sectors that are more susceptible for landslides and suffering active deformations. So indicating clearly to the Department of Roads what are the zones where we think that a focus have to be put. And also providing also the context for a monitoring capability. So if in the future the user want to use these techniques, can monitor again and again in the same manner for years. What have been the impacts that we detected more important in this case? For example, support the evidence-based decision making. So providing data for decision, providing a synoptic and consistent outputs mapping in large, distant, and accessible areas, zones without which this type of products would be very expensive or even impossible to assess. Detect retrospective hazards and also projection to the future and existing and projection to the future hazard. And finally, providing a tailored products that that address specific requirements provided by the users. The potential is very high in our opinion. It can be used for infrastructure relocation assessment, so where to put the road if there is an event in the future, cutting on or destroying a segment, or identification of sites for continuous monitoring. So what slopes have to be monitored just in case they have to be secured. The second use case is in Bhutan, and we focused in two different districts. And I have to note that this is a demo exercise. So this study could be, for example, extended to the whole Bhutan, and this is one of the main benefits of Earth observation that can be applied to large areas with, relatively easily. Also with the processing capabilities of nowadays. And in this case, we demonstrated the value of Earth observation in two different districts, delivering this family of products. So again, update the existing landslides inventory because there was one on the past, but it's the same. It's to provide a landslide inventory used as observation. Providing also landslide susceptibility assessments, used machine learning techniques, and INSAR-based mapping of slope instabilities. So it's more or less the same schema as in Myanmar, but for a different area. Here I put online capacity building for Department of Roads, and in this case, it was not possible to do, but this is something that has gone with us during these 3 years, and it's an important part of the work. So it is not only to deliver the products, it's also to build the capacity of the World Bank teams at high level, to explain the value of the products, what are the potential applications, what are the benefits, and also probably the most important thing, what are the limitations. Both at high level, maybe to the World Bank teams, but also at low level to the technicians of the user organizations that they have to uptake the information, to use it smartly, to know what are the limitations, as I explained, and so on. So it is probably half of the work has been also to develop smartly this capacity building, so the information that we provide is as useful as possible. In this case, terrain deformation mapping revealed several active slope instabilities, some areas that should have to be monitored, confirming existing or new sites that were unveiled, and a classification of former landslide sites by level of activity. Hence, detecting zones candidates for installation of in situ monitoring devices, or for being measured either with in situ devices or with INSAR, with satellite technology, as we normally do. These are simply a couple of examples of what we delivered. So these are the zones that these orange and red zones are those that are more unstable and unstable, and should be monitored, of course, at least more frequently than those zones that are not so unstable. As you can see here, there is this is one of the limitations of the technique. In highly dense vegetated areas, the technique doesn't work very well. So we only have points of measurement in zones that are bare soil. Finally, in the case of Binlong, this was part of the city resilience program demo exercise. Alex, can I ask you how much time I'll have?
It's 10:35, so you're good on time right now.
Okay. It's still 3 or 4 slides yet. So in this case, I will talk about the Binlong case also in city resilience program, but I wanted to bring here because it is located in the same area, and also it is about the same thing. So it's Binlong is a city that is in the Mekong Delta, is suffering from floods every year, and also they have problems of subsidence. So they knew that they had a problem, but they wanted some more information on where this was happening, and to start a reflection on what measurements or infrastructures of any type could they use for stopping the regular flooding of the city. In this case, it was provided full resolution INSAR mapping of subsidence, also exposure mapping with an integration of the land use master plan of the city and urban expansion layers provided by DLR, the WSF family of products, and a risk assessment that was performed by GSAT, one of our fellow partners. In this case, terrain deformation mapping revealed different patterns that I will mention here very quickly. Some macro patterns may be due to groundwater extraction, some localized patterns due to land use changes and maybe urban sprawl, impacts on structural integrity, some conclusions that they have to be taken with care, because it is important to say that this is a demo exercise, and if we have to investigate about what are the causes of these subsidence patterns, we will have to make a more thorough assessment also with engineers and other disciplines involved. This is an extraction of the impact and sustainability of the 3 projects, but I will go to the 2 last. I will skip this one. I will go to the 2 last slides that are about the benefits and applications that I think are interesting for the discussion. So benefits that can be perceived by the user. It is a competitive tool in terms of cost to support evidence-based decision making. So it is not, I mean, field work normally is quite more expensive than these techniques and cover more limited area. Services and products fit to purpose are fit to purpose and can be tailored for specific needs. We can make a production that is scalable, like that can be repeated again and again with not much more cost. There are online platforms that can be tailored for the user, etc. Provides a synoptic mapping of potentially distant, rough, inaccessible areas or large areas. Can look to the past and also to the future. Can shape mitigation actions, so can help to design better mitigation actions. Are complementary to the ground-based and other geospatial tools, and it can provide an early warning capability to protect existing investments. So it, as it's very rapid to be applied, can provide early warning quite efficiently. And finally, regarding applications, yeah, maybe it's a repetition, but in a retrospective manner, it provides basically 2 things: problem analysis and planning and forecasting. And also, it is very fit for proactive monitoring. For example, in evaluation of implementation actions, and also in the evaluation of effectivity of implemented measures and validation scenarios. So I hope I did it on time. I think I was a bit long, but this is more or less what we did in Inicia for infrastructure monitoring with our EO products and services. Alex.
Amazing. Thank you very much, Alberto. And in order to eventually discuss and comment on the specific use case, I would like to eventually invite Caroline Gebhardt, who is a remote sensing and machine learning consultant at the bank. Caroline, would you like to jump in?
Yes, thank you, Alex. And thank you, Alonso, for the presentation. It is really impressive, the work that you and the team did on so many different aspects of hazards, and then also when looking at the single application at the different stages, right? So on the one hand, moving from the analysis of the identification of where the hotspots are, but also towards understanding where they are, trying to predict into the future, and also moving into the end users to see how you can present the data in different ways, so that end users who are not even GIS specialists or remote sensing specialists can make use of it through dashboards and things like that. So that was very nice to see. Thank you. I had a question about scalability. So one of the large benefits of Earth observation data is indeed that it is scalable over space. That was also one of the things you mentioned of the second application, and also over time. And using also machine learning, once we train a model, we can theoretically also apply it to different areas, right? So in the previous discussion, there was also some talk about the costs that are involved in such a service. So on the one hand, because things are scalable, like Earth observation and machine learning models, once we learn, then theoretically also the costs would be reduced after a certain scale. At the same time, we know that machine learning methods may vary from context to context, and you will also need to always kind of adapt it to make sure that even though it is trained in a different area, it is still training here, or that it still works in a different area. So I was wondering if you could add something, if you could say something about the scalability and perhaps draw on the different projects to give examples of which aspects of the work that you have done are more scalable. So once they've been developed, they could very cheaply be applied to other areas, and which ones require a lot more local data and would be less scalable.
Okay, thank you for the question, Caroline. Well, with me, it is Jan Kolomatnik that maybe he can intervene. Before that, I would like to, align with your comment. We, in this case, we applied some machine learning techniques. We are applying machine learning techniques also in the detection of exposure, for example, in different areas, or on the detection of land use and land cover, also in different areas. And we are facing exactly the problem that you are talking about. We have a model that works globally with a limited accuracy. Then if we want to elevate that accuracy for specific areas like Middle East and North Africa, we have to retrain the model for that specific area, and that implies a cost. But even though, despite of that, we, the scalability is high. As soon as you have a base model and you retrain it in an area, and the accuracy is higher again, you can apply again and again in the same area, and especially for monitoring purposes. So with that model, you can use it. You can monitor monthly or yearly without much cost. That is my reading in general, and then I will leave Jan to explain a bit about this specific case. Can you support me here, Jan?
Yes, thank you. Thank you, Alberto. Thank you, Caroline, for your question. Regarding scalability of interferometric technique, in our case and our algorithm, we use machine learning, for instance, for post-processing purposes to detect some anomalies in the time series that were detected by this base technique. But from production point of view, I think the scalability is mostly driven by the fact that nowadays these algorithms can be deployed in platform environments. So speaking to our solution, we are using cloud, where we can deploy the algorithm, and we can scale the production pretty well. But there are also other solutions by other partners or that are funded by ESA. So there is, for instance, geohazard exploitation platform, which really allows triggering and production of this sort of product. Well, maybe at different resolution, at different detail, but for really large areas. So not only algorithm, but also the in production environment really drives the scalability. Speaking of transferability, I think it very much depends on, as was properly noted, it depends on the training inputs, which can result either from in situ measurements, or it can be outcome from another sort of Earth observation analysis. And in case of interferometric technique, the transferability works pretty well between similar areas, like in urban environment. But speaking of applications for infrastructure in mountainous areas, I think we are at the, let's say, edge of capabilities of the technology. So we are facing real problems related to different angles, topographic factors, and atmosphere, which is really challenges. And there is still quite a lot of development to be done to have really scalable and transferable solutions for this sort of environments.
Yes, we did know that the demo has been done with EO4SD in this part of the project, and I guess, as you say, then the model and also the production environment will help make it faster to implement in a different place, but there will still need to be some local adaptations if a different World Bank team would be willing to adopt this demo.
Definitely. Definitely. This technique really requires this approach.
Okay. Thank you.
Thanks a lot, Caroline, and thanks a lot, Jan, for the clarifications. Alberto, should we move to the second use case?
Yes, why not? I think you are going to end wasted of my voice, but anyway. Okay, let's jump to the next one. In this case, I did exactly the same as before, and I think it's it's useful somehow. So here the cluster is called Earth Observation Actionable Information for Disaster Impacted Areas. I'm putting the chrono. Sorry. All right. So in this case, we how to say it? We could help in two situations that were very critical at the beginning of the project. So unfortunately, there were two events that were dramatical in 2018 and 2019, and although this project of disaster risk reduction was not intended for response, we were, let's say, activated, or at least, we were discussing why not support resilient reconstruction of the areas affected by recent disaster. So,
do you have slides?
I'm sorry, yeah.
No worries.
Here we are. Okay,
Perfect.
so one of the cases, it is an earthquake that happened in Palu, in the island of Sulawesi, in September 2018. And you can see there the figures of destruction that are dramatic. 70,000 houses damaged, 200,000 people displaced, 100,000 of houses destroyed. We cooperated with the ADB and with especially, with a bunch of local users, but especially those, Ministry of Public Works and Housing and the Agency for Land Planning of Indonesia, providing damage assessment, terrain deformation assessment, because it was very useful in that specific case, and reconstruction monitoring. This was one of the most successful experiences in EO4SD, because the uptake from the user was very, very good. More or less, months after, there was these two cyclones affecting Mozambique in early 2019, with 600 or more than 600 direct casualties, 200,000 houses destroyed, and 160,000 people displaced. So figures that are more or less, similar in terms of impact, especially on houses destroyed. That is the focus of this case. In this case, the financial and technical support was provided by the World Bank, and the users, there were more than this, also the Institute of the National Statistical Institute and other, but especially the Reconstruction Office devoted for these two cyclones and UN Habitat, and the EO solutions were providing damage assessment, but it could have been also like a more complex or complete family of products like we did in Indonesia. The situation was that, unfortunately, months after the cyclones, Mozambique was still dealing with the consequences, not being totally able to cope with the level of destruction that they had. But at that moment, they were accelerating the reconstruction of households. They were deciding where to focus efforts, basically what houses to go for and what houses were not so priority. So we perceived that there was a situation where decision was needed to be supported. No, the actors I already mentioned: GREPOC, National Statistics Institute, UNHABITAT, World Bank. So the aim of the cooperation, as we saw, was to produce evidence-based assessment of house damage, to support decision-taking to organize either, the housing reconstruction survey, because these actors were putting teams in the field to analyze what houses were priority to be reconstructed or not, and hopefully to help prioritize reconstruction efforts. This is a 5-step approach in the demo. It's not especially, it's very regular. So we had to prepare the activities. We had to analyze what information, what images were available at that time, because there were not images tasked for our specific purposes. I have to note here that, as you may know, there are 2 different types of satellites. There are satellites that are taking regularly images of the whole globe in a systematic manner, that are normally high resolution or medium resolution, and then the very high resolution satellites that we were using have to be tasked. So if you don't ask the satellite to take a picture of your zone, you don't have anything, and that's one of the conclusions of this case. Elaboration of products, obviously, verification, validation, and users' final delivery acceptance, delivery of the products, and finally capacity building, train, and support, as we did in every of the use cases. What are the results of this experience? We selected 3 different areas in 2 provinces of Mozambique, Nova Sofala and Cabo Delgado, and the results. The product was damage assessment in these 6 pilot areas, with a delivery of a geospatial database, a visualization dashboard, provision of a series of maps for taking to the field if necessary. Also summary and explanation reports, a key for interpretation also, and also, as I mentioned, capacity building activities. The outcomes, seems that these areas are very small, no? But then you can see here the figures. We were able to assess in not a lot of time 38,000 buildings, of which 26,000 were damaged. If we put that in comparison with the estimated 200,000 destroyed buildings, is quite a few. So despite the areas are small, and the effort was limited due to the resources available, we were able to analyze a lot of houses, and that's, I think, something of value. We provide also a dashboard that I don't know if I can show very quickly here. So this dashboard could be used for any user, and here you can see the results where all the houses detected in the very high resolution imagery were identified, and there are some. There are different classes like not affected, rebuild, removed, not rebuild, etc. And this is based on the comparison of how was that dwelling before the event and after the event. So it's a comparison and very thorough and very smart classification, also because there is the need of a lot of training to do this properly. Finally, this is already the final slide. What have been the different benefits, limitations, follow-up activities, and lessons learned of this, no? And we can discuss on this with this slide with Brendan or whoever want to intervene after. So the main benefit is to assess the situation at large scale with limited cost. So in this case, it was only 6 different locations, but could have been applied to a lot more zones if necessary. Allows monitoring of reconstruction efforts. So it's not only to know what is the situation, how we can task the teams that are on the field, but also, okay, what is the status of the same buildings after 6 months, after 1 year, after, and then it is a good tool for the bank to assess how well are working the investments. And well, the first benefit was that, in our opinion, could have been a better planning of housing reconstruction survey. The survey is, as I was saying, it's there are task teams that are going to the field, analyzing the houses and the level of damage, and not only the level of damage, but also the socioeconomic profile of the families living there. So there are several factors that can affect if a house is reconstructed or not, including also some socioeconomic factors that cannot be obviously, or I mean, normally measured with satellite. But at least we saw that one of the benefits could have been to plan better this housing reconstruction survey. Some limitations. Yeah, as I was saying, decision on reconstruction efforts require thorough analysis of socioeconomic profile of households. There are some things that cannot be measured by satellite. Also, if there is a crack in the wall, we can maybe the house is about to go down, but we cannot measure with satellites. So there are limitations. Obviously, this is one of them. And another limitation is the timeliness. So probably our information was a bit late in the process. If people had been trained before, maybe they could have been used by our products better. And I mean, timeliness is very important. And 6 months before could have worked better. For potential follow-up actions. In Cabo Delgado, there were some there is a situation of terrorism and yeah, very delicate situation in Cabo Delgado that also is producing damages to houses. So this is a side positive effect of, I mean, not effect, but use of our products that can be used also for monitoring what have been the damage produced by the conflict there, and what were the damage produced by the cyclones. And also we were studying to extend the analysis to a whole province in order to, I mean, to the World Bank to have a better understanding of what was the situation. If these follow-up actions didn't materialize so far. Some lessons learned, not all of them, but yeah. Users need to be engaged from the beginning to optimal uptake, and yeah, capacity building action before or at the right time is would have been very useful. Yeah, need to be trained beforehand is the same. And important, ideally in this type of countries that are hit again and again by the same kind of disasters, it is useful to have at least reserved some budget for acquisition of images right after the event, the disaster, or even having a regular acquisition to analyze what is the situation and having a ground for comparing with a with the situation after a potential disaster. So these are this is my presentation. These are the lessons learned, and we can discuss when you want.
Amazing. Thanks a lot, Alberto. So I guess indeed we can hand over right away to you, Brendan. So Brendan Jungman, Senior Disaster Risk Management Specialist, who was supported through this one of those use cases that were presented, and more specifically on Mozambique.
Yeah, thanks, Alex, and thanks, Alberto. Actually, I made a few points of what do I want to say, lessons learned, and I actually see that many of them are on this slide. So it's great that we are very well aligned in what I think worked well and where more gains are to be made in the future. So overall, I think the support from the EU4SD program to our reconstruction project was very timely, was very valuable. We had a great and quite in-depth collaboration over a significant period of time with the strong technical results and innovative results. I think that also went a bit beyond what I was expecting we could get out of this. So as Alberto was mentioning, the government was really scrambling at the time after these two cyclones to understand what was going on in terms of damaged and destroyed houses. But interestingly enough, also to understand what was actually being reconstructed. There's so many NGOs working in the field. There's people reconstructing their own houses and partners coming in, and the government doesn't really know what's being reconstructed where and where the priorities still lay. And especially in Cabo Delgado in the north, it's difficult to get data. It's conflict, there's terrorism attacks. We can actually not really go to the field there. So using that geo information there was also our thinking of supporting the government with that and seeing how we can combine those different data sources. So based on experience in Nepal and Indonesia, the way we designed our reconstruction project was really to work through families who will lead the reconstruction process themselves and then get paid in tranches based on measurable verification of that reconstruction progress. So our thinking was also really, let's try to use innovation data to see how we can make this faster and easier. So yeah, personally, I was quite impressed with what we could get out. Knowing my way around a bit with the geodata, I was a bit skeptical at first what we could actually do with Sentinel level data and adding some more detailed information to look at actual individual properties. But as Alberto showed, I think it's it is quite possible to get useful data that you can reasonably use to at least get a first image of what is going on, where are the priorities, what are the damages, what are the reconstruction. Of course, you do need more detailed data. You do need to eventually go to the field, and combining those different approaches, I think, is where the challenge lies. And I think we learned something, and I think we should use that for future cases. So I think maybe, for me, maybe three lessons, things that I would take away. First, I fully agree, on the EO analysis makes it easy to analyze over time and also take snapshots at a very cost-effective way. So instead of sending teams to the field, you can relatively easily look at what was the situation immediately after the disaster, what was the situation months later, and do it more frequently. So I think that's very valuable. Now, related to that, I think my most important point, I think, is we need to go a bit more in depth to understand, what is the exact gap, as you mentioned on the slide, between what's needed for reconstruction decisions, what can be seen from space, and what part do we need ground validation. And that equation, I think, determines quite heavily what we can do with Earth observation data and where it doesn't make any sense, since we have to go to the field anyway. And this was really the struggle we had with the government, that they say, well, we do need to select the families. We need to know what the building materials of that house. We need to validate, even if it's still standing, it might be so damaged that we still need to reconstruct it anyway. We need to see what's the socioeconomic profile of those people. We need to see if they're interested in this support. So for them, they're like, okay, we have more data now, but we still need to do what we have to do anyway to go to the field and target districts. So how how do we combine it? And I think that's where we have to do something. And then the last point, I fully agree on. We need to establish more capacity in government, and I think working with a government that has some capacity in GIS, geoanalytics from the start will make a big difference. Here we had new government institutions, very weak capacity, and was the World Bank team who was translating the technical analysis for the government, which is not a sustainable way of doing it if you want to get the uptake in the end. So establishing that expertise, having a GIS specialist there, maybe paying for it, and making sure that's in place before we start delivering data, I think would be a very valuable thing in the future. But yeah, let me stop here, and thanks again for the great work, and looking forward also to the further collaboration under the next ESA World Bank partnership.
Thanks a lot, Brendan, and very good to know about those different points, and that you agree on most of those lessons, and the way also that it could be taken forward. Of course, the point about capacity building is also very important, and I'm sure that's something we will eventually discuss also during the panel discussion. But so that we're not too late on the session, Alberto, I'll just hand over to you for the last. Oh, I see, Sarah, that you have you wanted to react.
Yeah, just a quick question. What was the timeline for the damage assessment? Sorry, do you hear me? Okay.
I don't know the answer. I'm waiting for Alberto.
Actually, Angel, are you there? Do you remember what
Yes.
what was? Yeah, thank you.
I think, yeah, okay. For Sulawesi, I think it was less than a month. And for Mozambique, well, there were 2 slots with two different image acquisitions, and I think for each of them there were some about 2 weeks or 3 weeks, maybe, for each of the damage assessments.
Okay, thanks. That's quite fast.
Yeah, so it was. I mean, the length of the cooperation was more due to the discussion on what we were producing, what were the elements that that we had to identify, what are the classes that were interesting for the user, all that preparation phase. Also, acquire the images. Put them right to a correct geographical assessment. All that took some time, and then the specific assessment was quicker, and hence, repeat the analysis would have been more efficient. Every zone more analyzed would have been more efficient than the previous one.
Perfect. So Alberto, I'll just let you pursue with the last use case. Okay.
Let me also comment on the previous one. In the meantime, I'm preparing this. And regarding capacity building, it was a real pity that we couldn't go to Mozambique. I think it would have been a game changer for our demo to go there and to convince the users. I mean, we couldn't go due to COVID, but it is, I mean, in our opinion, absolutely essential or basic to go to the capacity building actions on site. I think we could have been more convincing and helping them to exploit the database, also understanding better what were the adjustments needs in our data and all that. Okay, I will jump quickly to the next one. So this is this use case is in this case is individual, is to render information from a space for subsidence monitoring in cities, and in particular the city resilience program. So the aim of the collaboration was to I'm sorry. Okay. So the aim of the collaboration was to demonstrate the value of Earth observation to provide citywide terrain deformation data for subsidence and to help decision takers to be informed about this hazard and and risk for a more informed decision taking. So here the program, our main stakeholder was the City Resilience Program, and trying to understand this program, we detected that it was especially useful to do it in two different ways. So providing two levels of details. There is a typo here. So first of all, for the City Resilience Program and for other cities, the idea was to provide medium resolution subsidence data, like generated systematically for several cities in an affordable manner, demonstrate that in particular, and then in two specific cases to provide bespoke and customized solutions for detailed analysis of subsidence. So in the medium resolution would provide the cities and the CRP and the cities representatives, either the World Bank teams or the users, like the institutions in the city, to have an initial assessment of subsidence of a bunch of cities, understanding, okay, I have a problem or I don't have a problem. No, basically that would have been the first thing, and then the high resolution would allow us to provide in detailed analysis of certain things and demonstrate also how far can go the technique. So this is the list of cities where we provided the medium resolution assessment that was performed by BRGM and using the platform called Geohazards Exploitation Platform. And on a selection of these cities, on Binh Long in Vietnam and Ban Chul in Gambia, it was proprietary solutions of GSAT and Planetec, our fellow partners, providing detailed, actionable information for supporting decision taking. This is the example of the results provided with the medium resolution assessment. So we provided terrain information on 9 cities around the world. These are the snapshots of those cities, and well, you only see stains here, like a green, but they are conformed of thousands and thousands of points for each city. So some metrics of this, it was for doing everything of this, it was necessary to process almost 600 images. We covered more than 9,000 square kilometers. Our observation period was 2017 to 19, with a resolution of 90 per 19 meters and accuracy that is very high, 1 to 2 millimeters per year. These are the outcomes. So you can see here a plot of how the subsidence of the different cities is behaving. No? In this case, it is not very. It is only negative values. So you can see here what is the millimeters of deformation per year, from 0 to more than 2, and what is the percentage in the y-axis? What is the percentage of the points that are having that measure? So, for example, in Yangon, there are quite a few, almost 5% of the city is suffering a subsidence of more than 2 millimeters per year. That is quite high. So these are the outcomes. You have an idea of the subsidence of several cities at the same time. You can compare it. You can make analytics. There is, a lot of information here to extract from the data that we produced. What are the benefits? Quickness. due to the use of the geohazard exploitation platforms that have access direct to the data, that have cloud processing capabilities that are astonishing. It is precise. 1 or 2 a precision of a millimetric precision is, I mean, very valuable for this kind of assessments. Is affordable due to the use of the platform that I mentioned. Is valid for initial assessments and allows comparison between cities. So these are the main 3 outcomes. No? We demonstrated the quick and low cost investigation of a subsidence hazard, combined with capacity building activities. The practitioners of the World Bank can even use our platforms to produce this data, like systematically or at demand, whatever. But can be tasked even for the World Bank teams, and it's a good tool to support the decision of if it is needed to do a more detailed assessment or customized service. No? So if you detect that there is a problem, then maybe it's time to invest some money for doing customized assessments, hopefully with satellite information. These are our regular outputs: subsidence databases, reports, and time series. That's quite normal. This is a sample of a map. Well, this is the same, but for Bangladesh. In this case, for example, in Khulna in Bangladesh, the area of interest is this 350 square kilometers. 49 Copernicus images were used, but the system can ingest it even more or more years, so that's not critical. And this is the algorithm that was used. I mean, it's some technicalities, but I wanted to show some results. No? This is the distribution of terrain information with 6% of the points with more than -5 millimeters of subsidence, some differential subsidence in certain areas that eventually can be coupled with some causes with the help of engineers and other specialists and so on. This is how the profile of a point looks like. This is how it's behaving on the time and how it's subsiding. And this is the line that shows if there are differential movements along time or not. For doing all this, it was used this geohazard exploitation platform that was promoted by ESA, and that is a very I won't spend a lot on this. It is a tool. It's a collaborative tool that is affordable, that can be used by non-specialists as far as some principles are understood. And it's a very efficient way to to have at your disposition a lot of different processing chains that otherwise would have been very difficult for anyone to put in the same place. For knowing not only subsidence but other optical and SAR images related services like detection of changes or I don't know, a lot of things. There are a lot of processing chains. This platform make use of all the catalog of Sentinel-1, Sentinel-2, Sentinel-3, Landsat 8, and also even other commercial satellites. There is a whole system to monitor what you are providing. There is a personal cloud storage. I mean, it's the usual stuff of the platforms that help you to perform your work better. And also it made use of the whole plethora of cloud computing capabilities that Europe is developing, and not only Europe, but also, I mean, Amazon Web Services and other cloud computing capabilities. As I was saying, there were 2 cities where we provided customized services. One of them is Banjul. In the Gambia, we provided a whole demo exercise with measuring subsidence, measuring storm surge by Argans, our fellow partner, also bathymetry, and also providing insights on exposure of Banjul, no? To different hazards, including also inland flood hazard. But in this case, this customized analysis formed part of the other demo exercise. So the tool that we used is called Reticus. Is one is a proprietary tool of Planetech, of one of our partners, and allowed us to provide an in-depth analysis of subsidence in the area and demonstrate the value of these tools to perform analysis. So I have here some slides showing that some data here with the area analyzed, with the number of images used for performing this analysis, 65 Cosmos SkyMet images with 3 meters of resolution, with the precision that is the same as I explained before. And we can see that the whole area is not subsiding, basically. So here there is no, I mean, we didn't detect a very critical problem. But there are especially some areas that that are subsiding, like for example the pier in the port is subsiding, and here is more or less the same as I saw just before. This is the profile of one specific point. So I wanted to show you. I mean, this is the tool that is a very efficient tool with which you can do a lot of analytics. You can, for example, filter the points to show you where are those that are subsiding at a higher pace, and detecting what are the zones that are more critically affected by subsidence. In this case, well, it is. You can see here that probably the old Banjul is the area where there are more red and orange dots, and is the area that potentially is subsiding more. If you click on one of these points, you can see the time series and analyze if there is some differential subsidence in certain moments due to, for example, events that took place, or I mean, man-made or natural events that took place in certain moments. This is only to say the deepness of the tools that we are able to provide, and the and also the precision that we, I mean, yeah, the deepness and precision of the tools that we are able to provide to any World team. And finally, Binlong, that is that I was mentioned before. It was also part of this use case, and I wanted here to, I mean, to put some examples only. So the objective was to estimate the land subsidence indicating intensity terrain deformation, and their spatial and temporal patterns is exactly the same as we saw in the previous examples. And also, this was the difference with respect to the previous. Here we provided a whole risk assessment, also mixing exposure and subsidence with exposure. So it was a whole work to analyze, okay, what buildings are affected, what could be the are the expansion of urban areas more or less affected by subsidence and all that. So this is the regular plot of the points with the different subsidence, with the subsidence of the different points. And here GSAT made the effort of clusterizing different zones with differential subsidence. So after clustering, assigned it to different urban blocks, so the reading is much easier, and by the user, and also the link with the potential causes is also easier for the user. Apart from assigning to urban blocks or certain urban areas, it was assigned also to specific infrastructures. So this is the subsidence rate assigned to the road network. Hence, analyzing, providing a view on road exposure. And finally, this is the relation of subsidence with urban expansion. For example, this there was a whole report explaining this, but here are the three. I mean, there are some clusters of subsident new built-up areas, in contrast to the subsidence in the old built-up area. And this is the example. I mean, the slide with all of them. So this is my presentation of City Resilience Program regarding the three different experiences that we made.
Thanks a lot, Alberto, for the detailed presentation in this use case. Maybe to finalize the presentation of the use cases, I would just like to hand over to you, Stephen. So Stephen Rubini, on behalf of the CRP team, Disaster Risk Management Specialist, I'll just hand over to you if you want to comment on this use case.
Sure. Thanks so much, and Alberto, thanks for the excellent overview and presentation of the work that was done, and to the broader team that contributed to to everything that went into the study. I think from my side there are a couple of things. One is just sort of related to subsidence in general. I think, coming from the DRM community, it's always been something that, we know has been a serious issue in certain cities around the world. Everybody's kind of heard of, the case of Jakarta sinking and that sort of thing. But until very recently, it's something that's been quite expensive and difficult to really understand at a granular level, or to be able to understand in any affordable manner, unless you want to sink a large TA project into a very specific topic. So I think we'd been tracking a bit some of the advancements on the Earth observation side for looking at subsidence, and thought this was a really good opportunity to look at it in a couple of different ways. One is a bit tied to our philosophy around the CityScan product, which I'd imagine many people are familiar with at this point, which was, okay, so there's this geotech platform. You can find a way to get a sense of the subsidence in a city quickly and cheaply. Is this something that we can bring to TTLs, in a more standardized manner? To open the conversation around whether subsidence may be an issue in your city, to have that initial dialogue with clients, and to make a decision about whether it's worth a more substantial investment, which we were able to get into in a couple of cases using Earth observation data, for example in Ben Long. Where I think it's really interesting to look at the infrastructure that was exposed to to it as well. Just learning some of the nuance of subsidence, bringing it to different cities in a way that is both sort of cheap and affordable and provides next steps if if they want to get into it a bit more. And then actually seeing some of it incorporated into World Bank projects, so I know in Georgetown and Paramaribo, some of this actually went from the initial stages of informing some of that early stage dialogue with clients into actual further downstream into decision making around investments. There's also been some other follow-up work from other teams. So the water team in Mexico City, they saw this work and decided to take it forward a bit independently. And I think at this point, it's still advancing quite rapidly, and I'd like to find some sort of way to to advertise it a bit more, both within our GP and and across the bank, about what's available, because it's it's definitely a topic of interest. It's something that I think many people are aware of, but in most of our discussions, it's not necessarily sort of the first challenge that many of these cities think about when they're addressing their own urban development planning. So yeah, I in terms of lessons learned on our side, I think the key lesson is that this is something it's a topic that is of interest. It's also something it's a bit challenging still to make the leap of saying this is the key issue facing your city, and and even if you do that, what can you do about it? So is subsidence caused from groundwater depletion, as it may be in, say, Mexico City? It's taking that next step into actually figuring out what types of investments one needs to consider in order to to do something about the problem too. That's something that I could be a growing business line for the World Bank, but we're still, I think, a ways away from from having something a bit more consistent in this space. So so I see this as very important pilot, and capabilities of Earth observation will only improve. It'll only become cheaper. Being able to I'd like to see some sort of intercity comparisons going forward, and and some studies come out on this, and hopefully this is something that that teams can build on and run with going forward, and can be more in sort of the baseline of what teams consider when they're thinking through some of the urban development challenges that their client cities face. So I'll leave it at that and push it back for the discussion. But again, thanks to Alberto and the team for this work. It's truly impressive.
Thanks a lot, Stephen, and thanks a lot for raising those points that are indeed also pertinent for the panel discussion. So, indeed, I would like to continue directly and move forward with the panel. And so, for the panel today, we have Enrique Brecht, Senior Disaster Risk Management Specialist. Thank you very much for being here. Megan Mukim, Senior Urban Economist, and Sarah Antos, Senior Land Administration Specialist. Thank you very much to all of you for being present. So, indeed, the idea here would be first to have eventually your reactions or comments on eventually those use cases, or on the main questions for the panel, which I can display again, but that were shared with you a bit in advance. So feel free to jump in right now, or I can formulate those questions again, whatever you prefer.
Really
might be useful to have the questions just up there again. I've completely forgotten. Thanks.
Sounds good.
Sorry, Sarah, you were speaking.
No worries. No, while you pull those up, I was just going to start off by saying, I think that the engagement between European Space Agency and the World Bank has come an impressive way. And I remember when it first started, and I was working on a damage assessment for Syria, and the the amount of time it took to get all of this stuff done versus like what you just presented. And I think also the quality has really improved. So I would say kudos to all that have been involved in it.
Thanks a lot, Sarah. And indeed, we're constantly trying to improve, going in this new phase 2, which The point of today, of course, is to have some lessons and insights from what was developed so that we can fully integrate this and gear the new phase of the partnership in the right direction. So, Mega, did you want to comment on some of those questions?
I see, because I asked for them, I must be the first to go. Yeah, so I mean, okay, maybe I start with the, let me start with the first one, right, which is just about at what stage of the project cycle the teams actually use this information. I guess usually, from my point of view, usually the space and the resources that are available to task teams to use this kind of data is normally when the teams are undertaking analytics, right? When there's a separate code and time and resources that have been set aside specifically for that purpose. And this is from my own experience, but also having observed other teams, that this is really when teams are working on the ASA/TA products that such data is demanded and being used. A marked exception, of course, is, also in some of the examples that were shown, is when there's an urgent requirement to respond to clients. So, for example, if it's part of like a PDNA, like a post-disaster needs assessment. In our case, for instance, we had to respond to the Ministry of Finance in Zimbabwe, who was in a tearing rush to find a way to identify pockets of poverty in urban areas in Zimbabwe, so that they could provide them with cash transfers following some of the strictest lockdowns in Southern Africa. Or more recently in ECHA, there's an urgent need to sort of understand migration patterns because of the war in Ukraine. And so I think there's sort of an untapped potential, because much of the analysis ends up being used is actually fed into the design of operational projects in the urban land and DRM sector. But when the teams are actually in the midst of designing the operations, they may not realize how this data can be utilized fairly swiftly and, at low cost to inform their project thinking. So in one way, I think that there's maybe a slight disconnect between perhaps the majority of ways in which the data is being utilized, properly versus how it actually could be scaled up. Thanks.
Thanks a lot, Mega. Sarah, Enrique, feel free to jump in.
Yeah, thanks. Perhaps I continue and actually pick up on the point that Mega just made, namely on making the connection and how to really use the data. Basically, one of the questions was how to improve adoption of the data, how to improve the usability of the data. So I was also one of the beneficiary of the Myanmar case study that was presented at the very beginning. I was the task team leader for the project. And there, I think what would be very crucial is, that we use this data that was created on the landslide hazard risk, and continue to work with a design consultancy that then uses the data to design landslide prevention purposes and design the roads in Chin State in Myanmar, so that this engagement goes one step further, instead of delivering a map, but also continuing to be engaged in the project. I would like to make a few other points on the adoption. So the first one is, it would be useful to have a broader approach, to not only look at directly the task team and the client government counterparts, but engage also non-traditional stakeholders, for example, the younger population, through hackathons, through internships, engage the private sector also for monitoring, engage CSOs. So to also have non-traditional actors engaged in the creation and in the uptake of the data. I think that this community outreach would be fairly critical. And then the second is, don't just stop at the delivery, but go further. Don't just produce, a land use map, or but rather look at, okay, a specific question. So, what causes the tree loss in a specific area, or what policies could follow if, for land subsidence, etc. So, be further engaged. And the third one would be to help create more extensive spatial databases. So in the work, and we've been promoting this quite a bit in this space, but actually there's really very little data available in public spaces to have, you know, a comprehensive inventory for a region, for a country, for a state in India, which you know, collects all available public data. And I think you know, one requirement for this satellite data analysis is that it will be made publicly available in a common data depository that this country or state has. So just promoting this data public access, I think would be very critical, and to really look at truly open cloud services, to look at really how to make this data more accessible that is being created. I think that is critical. And then perhaps finally look at instead of delivering maps, basically also you could think about delivering consultancy services to task teams. So let me compare that to you know, our unit works on climate change, and we work across all sectors and GPs. Whenever there's a new project, we engage with the task team, no matter which sector, and make suggestions on how to incorporate climate change in the design of the project. May it be a social protection or digital development or a transport project. So, you know, this kind of support could be given to task teams, you know, what could be done with Earth observation. And, you know, those, it doesn't necessarily mean that this study would then be financed, but it could also be financed, you know, from grants, grant trust funds or grant resources that the task team could have. But just giving task teams ideas of how to, you know, what could be the low-hanging fruits, how to better use satellite imagery, I think that could be very useful. So I'll stop here on the adoption part. Thank you.
Thanks a lot, Enrique. And eventually, Sarah, I'll hand over to you quickly.
Yeah, sure. So I can continue on the adoption. No, those are some really great points in thinking about the sustainability of things. I think another critical thing is to make the financial argument for it. I mean, it was mentioned that most of this work is usually bank executed, funded by TAs, because there isn't the financing and the preparation budget, which is all very true. But I think that we as the bank could do a better job at making sure that clients understand that there is financial benefits to using some of this data. And, you know, Stephen mentioned that this work used to take weeks to try to figure out the subsistence, and it used to be this, you know, very in-depth analysis. You'd have to hire lots of experts, and now ESA is making this data much more free, open, and on these easy, you know, user-friendly platforms. So I think informing clients about that is something that we can do better at. Let's see. I mean, I think that the bank is also really great at doing lots of pilots, like running around, collecting data, getting pilots, getting people excited. But then that transition from moving to a pilot, obviously, to, you know, getting the work integrated and financed into a project is, of course, the challenge. And I think to do that, what the key is isn't necessarily to have the client have the capacity to do the work themselves. You know, they're not maybe going to, you know, Ministry of Housing isn't going to have some machine learning, remote sensing expert, but have them comfortable with, you know, being able to hire or hire consultants that can do that, being able to speak the language, understand the principles, I think is another critical component of trying to achieve client adoption. Other things I would think about is some other practicalities. Like, so if you are going to start a project that's very data intensive, thinking through not just running around and collecting the data or capturing and analyzing the data and producing the maps, but figuring out who's going to be responsible, how's the data going to be shared. Some of those practicalities I think need to be thought through in the beginning. And I guess that kind of leads me to my last point about adoption is would be the data sharing. I mean, that's, of course, I feel like everybody already knows that, but I cannot emphasize enough how many times I've seen, you know, various agencies and institutions that we're working with produce great data, but just share PDF maps of it. And I think that's where data goes to die. So making sure that like we help and encourage data sharing is also great for adoption and sustainability of that data. Thanks.
Thanks a lot, Sarah. And thank you to the three of you for those very interesting points. Indeed, I think that there is huge challenges that we always try to overcome when we want to go from a pilot to something that is well integrated at the World Bank or in the systems and in the institutions of client state countries. And we have, of course, this dilemma between trying to do something that is large scale or regional and really having the buy-in of local institutions. And that's something that is, of course, not easy. And as you were mentioning, connecting with the local stakeholders such as the communities, I think is a very good point. And that's something that the World Bank is also working on through the Digital Youth Partnership Program, which I will eventually present very quickly after this discussion. Informing, I think the point also about informing clients about the financial argument is really key here. Is really about telling them, okay, what's the cost and what's the actual benefit that you can expect, and having those numbers right and those arguments right, you would and could really have an impact on how this narrative is built and how people adopt actually those technologies. And again, the data management also topic is really something that sometimes is lacking. So definitely agree on this one. And the fact that instead of delivering maps, as it was mentioned, it's really now more about is there consulting services or a platform, or even if we try not to multiply and have 20 or 30 platforms, eventually give access to an API that then can be integrated in different platforms. So all those are I think, very good points that we really take and will take into account in order to gear the new phase of the partnership in the right direction. So actually, thank you very much for this, and I've taken note of every one of those points, and will make good use of it. Mega, I see that you want to comment.
Yeah, just to say something. Just I thought of something when Sarah and both Henrique was speaking, right? So I guess I would sort of ask myself a couple of questions as you're thinking about scaling up. So, and it's just a summary, Alex. So, you know, nothing really groundbreaking, but the way that I was thinking about it to organize my thoughts is, you know, the first question is really what is really the problem that your data is trying to solve, and is solving this problem going to have a large impact, you know, on people, processes, places, whatever? Could this problem actually be solved through other ways? And so this may not be the only or even the best way to tackle the problem, right? Another question is, of course, will there be spillovers? Coming back to what I think Sarah was saying, is that are the learnings from a particular case going to be valuable for other countries or clients or task teams? Perhaps they're dealing with similar challenges, or perhaps the techniques deployed are going to be more relevant to other problems, you know, that are relevant in another context. And then the third one, you know, is what is your dead weight loss? In other words, would the team have gone ahead and done this work anyway, and thus your resources would actually have been better spent on another team or a case that would have been unable to move without your initial support? And I don't know how exactly you would go about evaluating that, but you know, that would be one way of thinking through how to spend your scarce resources. And then the last one, which is actually very important for me, and I don't know to what extent this is going to drive your decision-making processes, what is the confluence between the people and the projects? So even projects that meet the other criteria, you know, whether there's a problem to solve, if there's spillovers, or what's the dead weight loss, the project could still be fairly difficult if the technical and implementation ability of the task teams involved is going to be lacking. And those use cases that sort of hit upon the sweet spot, which is, you know, the projects and the people, presumably are going to be the most rewarding, but also are going to be the most fun going forward. Anyway, just a couple of thoughts to paraphrase what you also said, Alex. Thanks.
No, thanks a lot for this, and I think indeed there's different ways to engage with World Bank teams or kind of state stakeholders with somehow different objectives. Sometimes the teams and the knowledge of those teams is mature enough to think about a scale up, and sometimes it's just about awareness. That depends where we are exactly positioning ourselves on this kind of cycle or path of adoption, which starts with awareness and then eventually ends up by having a service or a product being scaled up. But yeah, thank you very much for those points. So if there is no further comments, I will jump to the last. Oh, Sarah, yeah, please feel free to.
Sorry, I just wanted to come in with one more thought I had. So you asked, where is there significant untapped potential, and one of the things that we're all seeing is that there's lots more pressure for increasing climate co-benefits in projects and figuring out how to do that as we design projects. I see that, and at the same time, I'm seeing like these great new, Sentinel-5 imagery coming out of like air quality monitoring, and this amazing, level of precision. So I think that there's this push to make our projects more green, and then there's also these brand new measurements. And I haven't yet seen it work, but I think that would be a great way if we could start looking at, pre-intervention, post-intervention, looking at some of the air quality and greenhouse gas emissions, sensors that ESA has. So I haven't done it yet, but I think that's, just putting it out there. I think there's lots of opportunity. Thanks.
I think it's indeed a very good idea, and that's something that we're also trying to explore right now. And having indicators or measures related to air quality or, for example, GSG emissions, which can eventually be done using Sentinel-5, 5P, or also through some other data. And then, for example, there is some companies such as GHGSat that provide data, for example, on methane emissions, let's say, and that are third-party emissions, what we call third-party emissions of the European Space Agency. And therefore, this data can eventually be accessed. And we are thinking right now about how we could eventually position ourselves on this topic, which I think is, as you highlighted, very, very strategic right now, and something that will grow in the next years indeed. But yeah, thanks. Thank you very much for this. So I'll move now to the last part of this event, which is a quick presentation on the way forward, basically, and what we can think about for the next steps. Let me pull quickly the presentation. Okay. So before closing the event, I would like to, as I was mentioning, present the next steps of the World Bank ESA partnership, and more specifically the implementation of the Global Development Assistance Program, which will benefit from the lessons drawn from the GFDRR initiative. So thank you again very much for all of those lessons, because this will really help us in thinking the way forward for the different engagements that we're organizing right now. As mentioned earlier, the collaboration between the World Bank and ESA has been going on for almost 14 years, and with the EU4SD initiative coming to an end, a new phase has started with the implementation of the Global Development Assistance Program, also called GDA. And so the main objective of this program will be to ensure the mainstreaming and transfer of Earth observation technologies into operational working processes and financing of development aid. Therefore, over the next 5 years, this program will carry out the technical knowledge developments that are required for new types of environmental information arising from development operational needs at the World Bank. And this could mean the development of informational products, value-added data sets, or analytical platforms to be adopted by World Bank teams and, or, as we're mentioning, client countries, which is the final objective. Those developments will be taken forward by consortia of companies recruited by ESA for each thematic activity, which you can see here. And so the initial sectors to be addressed and that have already been kicked off include climate resilience, disaster resilience, fragility, conflict and violence, and urban sustainability. And the rest of the sectors are planned to be kicked off before the end of 2022. So for each thematic cluster, several projects or programs will be identified and supported through a period of 18 months, organized in smaller iteration cycles of around 5 months. The idea is that each iteration will aim at delivering a product or service and will be implemented through an agile approach with continuous exchanges with the team and feedback loops. The main priorities of the program will be to support the development of products and services that first are demand-driven, in the sense that the need for the specific Earth observation product or service arises directly from challenges or needs expressed by World Bank teams in their operational processes and projects. Second, that those products and services have high potential for operational uptake, meaning that there is potential for them to be adopted by either several World Bank teams, different client countries, or that they can be scaled up later on. And finally, that third, they are innovative, meaning that the focus will not be on already mature and readily available products, but rather on services that require a minimum level of development or customization. However, what I also wanted to emphasize here is that, and that was also highlighted actually in the discussions that we just had, is that in order to ensure that the integration of Earth observation technologies is sustainable and scalable, supplying innovative tools and technologies, which corresponds to the support provided by ESA, needs to be complemented somehow with other activities. And in particular, it needs to be matched with a clear and structured demands in client states. And given their expertise, development banks, such as the World Bank, are really the best positioned to fulfill this role by generating the right channels of partnership, doing capacity building, ensuring that local systems are mature enough, and also encouraging the respect of ethical standards. So this is precisely what the approach of the Digital Earth Partnership Program is about. This program is hosted in the Global Facility for Disaster Risk Reduction and Recovery. And this program really emphasizes co-creation of geospatial data with local stakeholders, local capacity building, skills development, and ethical frameworks for disruptive technologies. The activities of the Digital Earth Partnership Program are organized around 3 pillars: a global knowledge pillar, which aims at strengthening the bank's position internally and externally as a global knowledge base; a partnerships pillar, which is aimed at facilitating the collaboration and implementation of the partnership with ESA and other technical partners; and finally, an operations support pillar, which provides demand-driven technical assistance to inform the design and implementation of operations. So the main message here is that through the complementary activities of the ESA Global Development Assistance Program and the Digital Earth Partnership Program, and also taking into account the lessons from the implementation of EO4SD, the objective will be to go further in the mainstreaming of Earth observation technologies in World Bank operations and in client state countries. We're finally reaching the end of this event. I would like to thank everyone for their participation and contribution. The elements that were presented and discussed here will serve us very well in the implementation of the new phase of the ESA World Bank Partnership. And of course, if you would like to know more about the services that can be provided by the companies which presented the use cases today, or about the GDI program, about the DEP program, or how your team or project could benefit from our activities, do not hesitate to contact us directly, me for the ESA-related activities, or Edward Anderson for the World Bank Digital Earth Partnership Program. The recording of this session, like the other 3 thematic sessions we are organizing, will be available on the Open Learning Campus so that people can view them later and can come back to it. And on this final note, I want to thank you very much and have a great day, afternoon, or evening. Thanks a lot, everybody.
Thanks, everyone. Thanks, Alex.
Thanks,
Bye.
Thank you. Bye-bye.
Thank you.
Thanks, Alex.
Thank you so much.
Thanks. Bye-bye.
Goodbye.